All right, let's do lesson 1, right? Okay, once again, this is just an old notebook, not a very good one. But let's just take 2 numbers. And in the comments, if you're really picking this up, you can say, you know what, I'm going to give you another problem to do. And if you want, I'll show you how to do that one. You pick the numbers. We're going to do 2 3-digit numbers. That's the symbol for numbers. It's not a hashtag. It was the number symbol first, but it is also a hashtag. So hashtag 3 digits. Anyway, 2 3-digit numbers. We'll do adding first. We'll add them and then we'll subtract them. And using number line. That's some very healthy handwriting right there. Using number line. Okay, so we're going to take our number line here. And remember, we're going out to infinity in both directions. But I need 2 3-digit numbers. So I'm going to take 1, 2, 3. So 435. And then I'll do 3, 6. I don't want to do 5s. Yeah, all right, I'll do 5s. Then I'll do 362. 362. Okay, so the first thing I would recommend when you're adding on a number line is to know where you're trying to get to. Am I going positive or negative infinity? Well, sometimes people confuse right and left, and that is okay on a number line because this is an open number line. So as long as you know your jumps all need to go the right direction, if you confuse what direction you're going, you should still be able to see it. Now, this will help you in calculus eventually, too, because when you're in space, you may not know which way is towards the Earth, which way is away from the ship. That's why right and left really is relative, meaning it's related to what you're near. So let's say you were going to add going in this direction. It would totally work as long as you remember that each jump that you make on the number line is always going in the same direction. This symbol is telling you which direction to go. So if you end up going this way, that's still okay. Just make sure your numbers count up in that direction. If for the purposes of the fact that most people do this, I'm going to do the opposite. So I'm going to put positive here. Positive infinity is over here. That's not an 8, that's an infinity. And negative infinity is here. And do you know how we make this right? It's pretty simple. When you're like me, this is how my brain can perceive things sometimes. So look at that, see? So don't let somebody tell you that's wrong, you went the wrong direction. As long as you get the correct answer, you did nothing wrong. Remember that. If your answer is correct, you did nothing wrong. This may confuse the brain, but look, if your brain is not working like most people's in the same direction, then fine. Just stick it together and follow the picture. So I'm going to start with my smallest thing here towards the negative. So negative, just put the smallest thing there. So I'm going to I'll take that number. Just because I can do eeny, meeny, miny, mo. There's ways to make it more clever, but you just want to make it work. It's more important you make it work than you do what just do what you think. I know this works, and I'm going to check to make sure this works. That's all you really need to do. Just make sure it works, because math and science is about truth. So if you prove it to be true, with your proof, you're doing it okay. If it ends up being false, science says that's a good thing. Science, something false, that's good. It means you learned and you proved it's not true. So we're starting in the negative, but I'm only starting in negative infinity, meaning that negative infinity goes that way. So that's just telling me which direction to count. So if this was 1, where would 0 be? Here. If this was 0, where would negative 50 be? Over there. If this was 19, where would 18 be? Here. if I wanted to count like most number lines that you see, and this was 18, where would 19 be? 19 would be here. If it was 25, where would 3,000 be? Here. But that's just because negative is over here. And positive is over there. But it really doesn't matter. I could even do it this way, but I'm just going to keep it simple because I've already taken 5 minutes and I'm amazed. It's amazing how fast time goes. All right, so 435 plus 362. Most important thing, double check those numbers. Don't write the wrong numbers down. I don't look at it sometimes and I write the wrong numbers. All right, so what do we want to do? 35. 35 is not a bad number. So if we jump 300, let's do that first. Let's take a 300 jump. That was the first rocket blast there, and it had 300. It had a positive 300 propulsion burst. Okay, it came out from the negative direction, and it had a positive burst of energy, and brought us up 300 to 4, 5. Don't count the number you're on. 5, 6, 7. So 700 and what? 35. 735. So we've already taken care of 300, so we can get rid of that. Going in the positive direction. Don't forget. This looks wrong to you. Don't forget. We just went from 435 to 735 by jumping 300. Don't forget. As long as you stick your own set of rules that work, that keep it true. Is this true? Yes. 300. Positive 300. Okay. So then we're going to do 6. We're going to jump 6, and that 6 represents a 60. That's right. So 60 is not as much as 300. So we've got 300. So half of that would be 150. Half of 150 would be 75. So our jump should look just like that. So we're going to make it about like that. That's a 75 jump, but our jump was only plus 60. Another rocket propulsion. We don't have as much gas. We don't have as much rocket fuel, so we can't go as far. We fall back to the number line, and we go from 35 to 45, 55, 65. That was 30, 75, 85, 95. So 3 plus 6 is 9. 796. We cross that out. You should really not cross it out until you make the jump. All right, so our rocket is now in the positive direction. Positive infinity over there. Positive direction, 796. What's an easy number that's pretty close? Oh, we don't have enough to get there. If we got to 800, we would need 4 more juice bars. Rocket fuels, but we don't have enough. So we're just going to do 2. So if we count up 2, we'll just do it real small. Plus 2. So we're going to have to zoom in here. And zooming in, 2 up from 6 is 6, 7, 8. So 798 is the answer that we have. Now, how do we check to make sure that's right? We check to make sure that's right. Well, the first thing we want to do is 2 as big a jump as 60? Not even close. So that's why I drew it so small. 60 is a lot bigger than 2, but is 60 anywhere near 300? Not really. It's like I said, it's about a fourth of it, less than a fourth of 300. So that's why we make it so small, because we know that halfway between the 300 rocket boost is 150, and it's less than that. It's less than half of that. So far, it's looking true based on our grid, based on our drawing. Again, negative direction, that way. Positive direction, that way. So we're going to flip P-doo-dah, and we check it here, and we say, okay, we started at 435. We did a 300 jump, and we made it to 735. We did a 60 jump, and we made it to 790. Uh-oh. I done bad. I'm so glad I saw that. Well, see that? That's why you proof it positive. So far, we have a false false numbers. 60 gets you to 70, 96, 95, not 96. I don't know. I must have gotten the 6 from there. But see, math, it's okay. That was false. So I double checked it while I was explaining it, and now I see. Now it's true. But now that is false, because 5 plus 2 is certainly not 8. So that's 797. 797. Let's double check that. A 300 rocket boost, and now instead of a rocket boost, we're swimming. We're the submarine's going down under the surface. Bloop, 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 and it comes back up. 735. Okay, getting some air, getting some air, getting some air. Then we dive down under the surface. 60. Come up at 795. That was a dive of 60. And then just a small bloop of 2 to get us to 797. Now let's double check that by doing another number line. And this way, we can reverse the direction. So now we have an open number line. It's supposed to be straight. Did the best I could. Okay, so 797. So now we got 797 minus, we're going to take away 435. And our hope is that we get that number that I crossed all out. Which I think, if I remember correctly, was that number there. But we'll see in a second. But this time I'm going to make, yeah, you know what? Let's make this a negative infinity. Okay? We'll make this a positive infinity, just to confuse us all some more. Positive infinity, negative infinity, which just means for it to look like this, it would go this way. But all positive and negative infinity is telling you is what are the rules of the direction? Towards, away. Towards, away. Okay, so we're going to start here and subtract. But we could start over there, as long as we remembered which direction we were going. So why don't we do that? We'll start here. And we want the bigger number. The bigger number, please. Please go the bigger number. But I'm going to show you why number line is great for big subtraction. Because as long as you're using efficient strategies. Like, how efficient were we? 3 jumps. If we only had 3 moves to communicate with the computer before our astronaut died, we could only give 3 commands. And this re-entry here would save his life. He survived. Let's say he only had 5. How efficient? If he had 5 and we used 3, we're still good to go. But that's efficiency. If you jumped 50 times, if you used 50 different commands, you wouldn't have enough and he would not survive. That's efficiency. Efficiency is coming in 3 jumps. So the most efficient way to get from, we don't want to be at negative infinity. We don't want to start at negative infinity, do we? Because then if we were going this way, we would be adding. So we need to start here. I wanted to reverse it, but I can't. Because my direction tells me subtraction goes this way. Losing ground and going towards negative infinity goes this way. So I know, based on just one thing, before I ever put a number on there, that I have to subtract. Start with the big number when you're subtracting on a number line. Take the biggest number. Okay, so now here comes where we need to start using second grade up to larger grade, higher grade logic skills. If we're coming down out of the clouds, we want to start here, or do we want to start here? Do we have enough? If we're at 7 and we want to go to 5, do we have enough to take away 5? Yes. So we can start there. If we start at 9, do we have enough to take away 3? Yes. So we can actually start from there. But if we have 7, do we have enough to take away 4? Yes. So we can actually start from the 100. As long as this number that you're subtracting on the bottom is bigger, you're still okay. All these numbers just work out. But it could be, let's say it was something over here. Like if I took the other number, let's see if the other number would do it. If I subtracted 797, if I subtracted 362 Looks like that would still work too. That would still work too. Well, I'll have to show you one more problem on the next time. Wow, this is already 15 minutes. Holy smokes. No kid pays attention for 15 minutes. So we're going to take away 400 from 7. Big jump. Minus 400. Just telling us we're heading from positive to negative. Minus 400. What's 7 minus 4? 6, 5, 4, 3. 6, 5, 4, 3. 397. Okay, so we can cross out that. 900 minus 3. 90, excuse me. Don't say that, don't do that wrong. 90 minus 3. So we're going to go from 90. We're going to take away 30. 30 is a lot smaller. So 400, 200, 100, 50. Wow, this is going to be really small, this number line. That's about 50 already. Minus, we're taking 30. So 9 minus 3, 8, 7, 6. 367. 367. Started at 797. Minus 40. 400. Ended up with 397. Took another 30 away. Ended up with 367. What do we got left? Cross that out. Got 5 left. And what I'm saying is you can only start from this. You start here and say, do I have enough to take this away from this? Yes. Do I have enough to take away this from this? If this number was bigger, this number here was bigger than this number, that would mean you'd need to start there. And it would also mean you need to borrow from there. But we'll do that on another problem. So anyway, the only thing we got left to do is take 5 more away. We have 7. Let's take 5. It's really small. So we know that's minus 5. Okay, that goes there. And it scales. This is what they call scale, which means 400 can't be as big as 5. Minus 5. That looks like plus 5. It's supposed to be minus 5. And then we come back 5 from 7. 7, 6, 5, 4, 3, 2. We are left with 362. 362 looks awfully familiar. That's a pretty good proof that this is a true statement. It's 18 minutes to one problem. No wonder it takes us so long. All right, thank you guys.